So this is a combined rates equation problem, and it's probably one of the only really difficult ones that we have in this unit. The other ones tend to be fairly straightforward if you have an idea of how to set up the equation, but this one is difficult because it's not telling you how fast one particular person is, how long it would take them to do it. Like Eduardo here, we have a job, he wants to appraise some houses, and it's not saying Eduardo does it in 10 hours or whatever. And it's not telling you how fast Levi does, but it's telling you comparison rates of how they relate to each other. So what we have to do here is we have to kind of build up some equations aside from our combined rates equations. We have to build up equations that just tell us how long people take. So I'm going to say, let's say Eduardo is E, and he's going to read this sentence right here. Read this sentence, what it says. He does it 66 hours faster than Levi. Okay, so let's make an equation that says that. E equals whatever Levi's time is, Eduardo's is 66 less. Okay, that's what I've just written here. And let's take the next statement. Eduardo, okay, we're still talking about Eduardo, and he works 22 hours slower than Levi and Eduardo working together. Okay, so think about that as an equation. Eduardo's time compared to the total time is 22 hours slower, so that's T plus 22. Now, maybe this Levi guy is, I don't know, he just got his appraisal license and Eduardo's been doing it a long time, so that's the reason for their differences. But we need to understand how long it's going to take Levi to do this job. And be careful, sometimes it asks for Eduardo, sometimes it asks for Levi. So you got to watch out who it's asking for. Now, here's how you plug them into your work equation. Remember your work equation. It's just 1 over T equals 1 over Eduardo plus 1 over Levi. Okay? But all I know is these E equations over here. So how can I put those in? What you have to do is you have to kind of rearrange these equations. Okay, so let me give myself a little space here. I'm going to show you how to rearrange these equations so they're useful. If E equals L minus 66, then that means E plus 66 equals L. And likewise, if E equals T plus 22, then I can say E minus 22 equals T. So hopefully you see why, or see how those equations work. And now what I'm going to do is I'm going to plug in what I know into my work equation. Okay, so let's go ahead and rewrite the work equation having plugged in this information. So I get 1 over not T, 1 over E minus 22 equals 1 over E plus 1 over not L, but E plus 66. And now you can see, take a look at this guy. This is an equation with one variable in it, and we can solve that. We know how to do that. All you have to do is multiply everything you see by denominators until you have common denominators. So I'm going to do that now. Let's see. Let me write my equation over again here. Just make sure we're all on the same page. E minus 22. I'm going to leave some space because I have a lot of stuff to write. Equals 1 over E plus 1 over E plus 66. Okay, there's my equation. Let's write the crazy ones that we need to make this thing have equal denominators. So E minus 22, the factor on the left, what's it missing? Okay, it's missing a factor of E, and it's also missing a factor of E plus 66. Okay, those are the crazy ones here. And now the factor of E, what's that missing? Well, it misses E plus 66 from the fraction on the right, and it also misses E minus 22 from the fraction on the left. And E plus 66 is missing just a regular old E, and it's also missing E minus 22. Okay, so now take a look. Everything's a common denominator, right? E minus 22, E, and E plus 66. Every fraction has all three denominators, so I'm going to go through every fraction and cross them all out. That's the trick I get to do with rational equations, which leaves me this. E times E plus 66 equals E squared plus 44E minus, whatever 22 times 66 is. I'm not going to do that in my head right now. And then plus E minus, that's an E squared. E squared minus 22E. Okay, so it looks like I foiled some of this and didn't foil other parts. Let's just keep on working with it. e squared plus 66e equals e squared plus 44e minus, still not ready to do that one, 22 times 66, plus e squared minus 22e. Now I want to combine everything. You see I have an equation here with e squared terms and regular e terms. So let's move it all over onto one side and leave 0 on the other. So my e squared cancels out with that. And I have 66e over here with negative 22e over there. So I'm going to move the 66 over. That leaves me with, well, okay, let's just do this one step at a time. Doing things in your head gets us into trouble. So I'm going to move this 66e over and write out the rest of it. 44e, let's get all our e's over to one side. And then I have this plus e squared here and minus 22 times 66. Okay, so that means 0 equals, I've got an e squared. Let's put that up front. It's easier for me to factor like that. And then negative 66 minus 22 plus 44, add those all together. We're going to get minus 44e. And then right here, I have this, let's just pull out a calculator. 22 times 66. It's very big. 1452. Okay, so it's a quadratic equation. All we have to do is factor this. So, what are two numbers that multiplied 1452 but add up to 44? So just like any other number, you just pull out 1452 and you try to make factors of it. So let's start with 22 and 66 because that was up here. I know those already multiply to 1452. And remember, it's negative 1452. So what if it's negative 66? Well, negative 66 plus 22, that happens to work out. So we've got e minus 66 and e plus 22. And that'll work out to be this equation right here. Okay, now that means we have two solutions to this equation. E equals 66 hours. This is Eduardo's time. Or E equals negative 22 hours. Well, I told you Eduardo was fast, but he's not a time traveler. So that negative time one is not going to work out. This is Eduardo's time, 66 hours. But now, remember what the question's asking for. It doesn't care about Eduardo. It wants Levi's time. So we have to go find our Eduardo-Levi equation, which is right here. E equals L minus 66. L minus 66. So that means Levi is going to take, well, add 66 to 66 and we get 132 hours. Okay, so that's the way you approach this style of problem. Just to sum it up, what did I do here? This was the key step. Okay, this right here was our big breakthrough when I rewrote our work equation using other equations for their relative times.